calculating reaction entropy using the standard molar entropies of reactants. So because entropy is a state function, we can define our entropy change for a reaction or process by summing the total standard entropy of our products and summing the standard entropy of our reactants and subtracting reactants from products. Because remember, for a state function, any change in a state function is equal to the final state minus the initial state. For a chemical reaction, the final state is products and the initial state is reactants. So we can define this entropy change as being the sum. I'm going to have to type this in a second. However many moles times our molar entropy for our product minus the sum of however many moles times the standard molar entropy of each reactant. Okay, so let me just draw those little squiggles in there for our sigma. Not very good at this. 1 sigma, 2 sigma, just meaning sum. And of course, these are all standard, so they all should have that little degree type symbol thing there, which again is terribly hard to draw. So maybe we'll just kind of bodge it a little bit. Something a bit like this, right? And I seem to have drawn a line through everything accidentally. So you're going to have to either look up in your textbook, or if you're working ALEKS in the data tab, you're going to have to look up the standard molar entropy for each of the reactants and products. So for my PCl3, that is going to be equal to 311.8 joules per mole per Kelvin. Then I'm going to do the rest for all the others. So standard molar entropy for my P4 is 280 joules per mole per Kelvin. My standard molar entropy of my chlorine is 223.1 joules per mole per Kelvin. And then we can do the math. Okay, so I'm going to just do this down here actually. So for my products first, I've got 1 mole of P4, and that is going to be times 280 joules per mole per Kelvin. So you can see that the mole bit that's going to cancel out. And then my other product is my chlorine. There's 6 moles of chlorine being produced, so 6 moles times 223.1 joules per mole per Kelvin. And that is going to make up all of my product side of that equation. And then I can subtract off my reactants. So for my reactants, I got 4 moles of PCl3, and the standard molar entropy is 311.8 joules per mole per Kelvin. So I'm going to end up with one number minus another number, and the units, moles are going to cancel out, so it's just going to be in joules per Kelvin. So use parentheses appropriately in your calculator so it doesn't get messed up. Sometimes you might want to check those parentheses separately. You should get 1618.6 joules per Kelvin for that first bracket, minus 1247.2 joules per Kelvin for the second bracket. So that is going to equal my change in entropy for my reaction to 371 joules per Kelvin. Okay, so just watch your reaction stoichiometry and make sure you use parentheses when you put this into your calculator, and there's not too much that should be able to go wrong with those kind of questions.